In after coffee. So I'll just introduce myself. I'm John Storkey from Rothamsted, a member of the organising committee of this conference, and I'll be chairing the next short session. It's a short session, but I think it's a very important one, because before we get into some of the detail and some of the science of the long-term experiments that will take up a lot of our time over this week, I think it's important, in light of what Achim has said, to take a step back and remind ourselves of the relevance of our experiments, or if our experiments are no longer relevant, challenge ourselves as to why they're not and what we can do about that. So this session is all about making long-term experiments relevant to informing and delivering policy at the national and international scale. We'll have two invited speakers, and after that we'll have a wider discussion amongst ourselves. So to stimulate our discussion, we've got two speakers who've been invited to help us with our thoughts. The first of those is my colleague, Professor Andy Whitmore from Rothamsted. Andy is currently the lead scientist on an initiative called the Sustainable Intensification Research Network, or CERN, which is a UK initiative coordinating groups working on different aspects of sustainable intensification in the UK. Andy has a background in modelling soil chemical and physical processes, and is currently leading a group here working on methodologies for optimising trade-offs between environmental and production goals, which is obviously very relevant to the long-term experiments and long-term data. Andy will be followed by Professor Bernard Vanlauwe, originally from Belgium. Bernard's now based in Nairobi at the International Institute of Tropical Agriculture, and is the Director for Central Africa and Natural Resource Management. Bernard's a visiting professor at the Swedish Agricultural University in Uppsala, and again has a background in soil science, but has also published extensively in the area of sustainable intensification in smallholder farming in sub-Saharan Africa. So hopefully these two broad-ranging talks will stimulate our ideas for the discussion afterwards. The plan is to have the two talks, one after the other, and between them just to have 5 minutes for questions on clarification on the two talks before we move to the panel discussion. So with that, I'll hand over to Andy. Thank you, Andy.
Well, good morning, everybody, and my thanks to the organisers for giving me this opportunity to talk to you today. I'm going to talk about the relevance of long-term experimentation to business and to policy. And I'm going to do this, first of all, I want to give you some examples of how I think the LTEs have been relevant to business and policy, and then move on to some of the things which, as John says, interest me at the moment, trying to look at trade-offs, trying to look at delivering multiple objectives, talk about some of the challenges and the opportunities that leads, and then perhaps to talk a little bit about what I think is missing and what we might be able to do about that with in future long-term experimentation. So just to set the scene, if you look at the top line of this and then move down, I really move from what I think is basic and fundamental science right down to the sharp end, and I think long-term experiments have something to say at all levels. So I think that the experimentation, and there's lots of examples of this, have been used to test hypotheses, which provides evidence that policymakers or business needs in order to take sensible decisions. I think moving beyond the simple effects that can come out of direct experimentation, it's possible to elucidate trends and infer causes, develop a theory, which helps in planning a strategy. I think, too, this, as John has mentioned, some of the things that I'm interested in, very often there are conflicts. Sometimes there are trade-offs, sometimes there are synergies between systems that a farmer or that land managers are working through. And you have to look at what might be acceptable, both to the public, but also to the business people or the policy involved. And then you want to look at trends, you want to find thresholds in developing a policy. And then, of course, you come to the farmer or the man or the woman who's managing the system as a whole. You're looking at the agronomy. You're looking at the whole management of risk. So to start with, I'll pick an example which is really why the long-term experiments were in fact set up. But going back a little bit in history, Jean-Baptiste van Helmont set up an experiment where he looked at how a willow tree grew. And he grew it for 5 years or so, and he concluded that most of the growth came from the water that he gave to it. He missed a small change in the mass of elements that or nutrients that were taken out of the soil, but it was left to Justice Vanlauwe to realize that the plant actually that willow tree actually got most of its carbon from the atmosphere. And he concluded, not unreasonably, given that carbon dioxide is such a tiny proportion of the atmosphere, in comparison, that the plants probably got their nitrogen from the atmosphere. But Laws and Gilbert set up the broad bulk experiment to demonstrate, to prove the hypothesis that plants obtain the majority of their minerals from the soil. When that was proved beyond conclusive doubt, and there was a bit of acrimony between Liebig and our forefathers here, when that was shown beyond doubt, Laws was all for grubbing the experiments up and using the land for other purposes, but Gilbert persuaded him to continue, and we have the network of long-term experiments here today that we wouldn't otherwise have had. A different example completely, Akim's already referred to this Rothamsted insect survey, which has had its own anniversary recently of about 50 years. James Bell, I'm sure, or one of his colleagues will tell you a little bit more about this later. But essentially what it is a huge, great vacuum cleaner, I call it, stuck up into the sky, which sucks out insects. And they've noticed the number of agricultural pests, in particular this one, Mysis persicae, fly or start to fly. They capture them for the first time after there's been a certain accumulated degree days of temperature. So it's the early temperature in the year that determines when these insects first start to fly. And they've noticed indeed that this is getting earlier and earlier in the year, almost certainly as a result of climate change and the increases in temperature. So that there's evidence of an environmental change happening and consequences of that for farmers. Another example, which comes from our Woburn site, where in the 60s an experiment was set up to test the benefits of applying sewage sludge to crops. Very sensible things to do. Part of the circular economy, you would argue today. But of course, what came with that were industrial wastes, such as heavy metals. And unfortunately, if you went back and sampled this soil now, during the 60s and 70s when they were looking at this, they found that the microbial biomass found the number of cells per gram of soil was a lot less on the plots that had sludge compared with control plots or plots that had only had farmyard manures. And this and other experimentation around the world was very helpful in setting thresholds for what was acceptable in terms of the loading of heavy metals from industrial pollution to soils. And then we've seen this diagram a few times before. I won't labor on it, of course, but what it shows is the agronomy, the effects of the treatment that carries out together with the crops that we're growing and how that is changed over time. But what I will just draw your attention to is a subset of the results that are over here. I'm plotting out a nitrogen response curve here, yield going up. But what you see at the bottom here is the response of a variety that was grown in 1880, this squareheads mustard down here. That's the response of that variety to nitrogen in 1980. And up the top here is the variety grown in the 1980s, brimstone. But in the middle, these red point, which are the significant ones, they are squarehead musters, the 1980s variety, grown in 1980. So that you can see the effect of the genetics, the old-fashioned genetics, and the modern management, or the then modern management, and it's about 50-50. So a lot of the development has come from scientific technology in terms of the molecular biology and the genetics, and a lot from the management and the various chemicals, methods of ploughing and so forth, which have gone into the agronomy and the whole system. So turning to multiple objectives, the ultimate series of multiple objectives are these Sustainable Development Goals, which many of you will be familiar with. One of the goals is zero hunger, so that relates directly to agriculture. But there are a lot of things in here too, such as life on land, biodiversity, for example, climate action, which I've just referred to, as well as clean water and responsible consumption production. All of these things, all of these goals Many of these goals are relevant to agriculture, and we, even in the developed world, as well as the developing countries, have a responsibility to try and deliver as much as we possibly can to these multiple objectives. So let's think about a few of these, because as John said, I'm interested in trying to deliver to these multiple goals, multiple objectives. But it's surprising how little data there is out there to try and develop computer simulation models of these things. So what I've got here is some data from the broad bulk field experiment, where you've got to understand that when you're looking to see if something's better, if there's an improvement, you're looking at two axes at once. So although I'm plotting out data on a yield axis here, which is getting better from left to right, I've plotted this out against nitrate leaching, a concentration, which is getting better as you move down the axis. So in general, this graph is improving, or things are improving, as you move from top left to bottom right. Now, having explained that then, the blue points are relatively modern data from broad bulk, and they're showing both the nitrate concentration and the yield. Well, what's in the green data here are from the 1880s. And again, the same plots. They didn't all exist in 1880, but you can see, and this really reinforces Akim's point about things getting better, that those lines are going from the same plot in 1880 to the same plot in the 1980s. They are all going in the right direction. Every single one of those plots has got better, both in terms of nitrate leaching and in yield. Yield you think about, nitrate leaching perhaps not. And I would argue that where things are better, you're getting better off. And in a sense, you're creating wealth by delivering to these multiple objectives at the same time. Another example, again from the park grass hay meadow, just briefly, number of species. I've confusingly plotted yield on the other axis here, sorry about that, but both axes are getting better. So things are improved when you go out and up, from the bottom left to the top right. And the message here is that some of the plots deteriorated as a result of acidification. Andy MacDonald explained some of this to you. But with liming, both biodiversity, both the number of species and yield increased. Akim referred to this too, a new experiment, relatively new experiment that's set up of our sister research institute in Devon, North Wick, where they're looking at the economic growth, economic value of growing these guys, live weight gain over time, and at the same time looking at the sediment, at the nutrients which are lost through weirs from these small fields here. And they're grown together in 3 different farmlets, testing hypotheses about the best way to manage livestock farming. Now, some of my own work is looking at what happens when you've got one of these boundaries. So these are results from computer simulation models. But what I'm exactly asking you to consider is how the nitrate concentration, in this case going in this direction, and income going in this direction, you hit a sort of boundary. It doesn't matter how you manage that field, you can't get very much more income, much more yield, without being a bit more polluting. And in this case, remember, 2 axes, but generally speaking, things are getting better as you go from bottom left to top right. Another field does somewhat better. What happens if you try and manage these two fields together? In fact, what happens if you try to manage a landscape together? Well, it seems that you can change the envelopes, and this is how economists manage the economy, a point I will return to later. You can keep management options out and still manage to reach this threshold in terms of minimizing the amount of nitrate leaching that might otherwise happen, and yet maintain your yield and your income by thinking about how to manage those 2 bits of land together. And that's generally a cooperative strategy for trying to increase the wealth and making society better off than it otherwise might be. So what do I think might be missing, therefore, from long-term experimentation? And what I've talked about so far is 2 of these pillars of sustainability. The economic one, yes, we grow food, farmers are entrepreneurs, they need to make money. And yet at the same time, we want to constrain them. We don't want to pollute the environment. But we haven't thought very much about this 3rd social pillar of sustainability. And I argue that perhaps if that isn't there, you've got a risk that this might happen. So what perhaps we can do about that? If we want to manage land together in order to try and improve multiple outcomes, In the examples I've got here, it's nitrate concentration, but it could be biodiversity, pollinators, it could be flood risk, things of that kind. While maintaining yield, I would argue that we probably need to network the fields. And if we're going to network the fields in order to manage them together, in order to get the most out of them, we're probably going to have to network the people. Now, I want to try a little interesting experiment here, and I want you to get your wallets out. Or your handbags. Come on, even you Rothamsted people, I know you're not used to doing this. Have you got one of those? Now, anybody need one? Is anybody short? Anybody? Yeah, see, these Rothamsted people, they so somebody say hand straight up there, you know. Anybody need that? Anybody need them? Anything like that? You know, anybody short? When I imagined this, I thought everybody would be on the front row, but that was really stupid, wasn't it? Now perhaps your neighbour hasn't got one. So could you share, please? No? There's people here who aren't looking. It's quite important you have one of these. No? Okay? So what, you've got one, okay. So what I need you to do is look on the back, all right? And on the back, you'll see this gentleman, Adam Smith. And there's some text underneath there as well, which refers to one of the passages in his book, which was called The Wealth of Nations. Remember that? I was talking about how we can make our society more wealthy. And it's really, you'd probably interpret it and think it was about industrialization, industrial farming maybe. But he was very interested in trade, in trying to get different countries to specialize in what they were good at producing so that they could trade and become wealthier. And he was arguing that these are modern ideas, these are ideas we just take for granted in the modern world. But actually, at that time, there was this movement of mercantilism, which was really a zero-sum game. And what he was arguing for is that if you manage the world economy together, we'll all be better off. Now, if you turn it over, you know, this is a double-faced, double-sided visual aid, you will see, I shall move on, oh, I should move this on, you will see some other words that I'll just draw your attention to in a minute. Now, how did it feel when I was handing out money? How did it feel when I asked you to share? Did anybody do that? What a nice man. So if you look at these other words, it says, I promise to pay the bearer on demand the sum of £20. So get real, people. This is a piece of money, piece of paper, sorry. We all will value it, covet it, but actually, all it is a symbol for something completely different. And what I'm trying to get you to think about is that we trust this, and we trust one another when we're handing these bits of paper over. But it's difficult. And if we want people to manage the landscape cooperatively, if we want to network people, we're going to have to engender an atmosphere of trust in order to get the best out of managing the landscape as a whole. Because what one person's gain might be another person's loss. But together, we could be richer. But this is a very difficult thing to do, as perhaps that exercise has illustrated. How do we go about doing that? And this is another lesson I learned recently. We had a workshop with some social scientists, and I was insistent that if they were doing science, they had to have a hypothesis. And they said, well, no, we don't really work like that. And I think we compromised in the end. But the trouble is that by the time you proved your hypothesis within the social sciences, it may no longer be relevant. It takes a long time to happen. And you could argue the same is true of the long-term experiments. There's a bit of a story that you think about, that there was a farmer. He was going around trying to get some advice. And he spoke to one group of people and said, well, can you tell me how much fertilizer I need? Well, yes, sir, but are you a member? Before we give out any advice, you need to be a member. Somebody else, he went to, well, you have to pay if you want some of the advice that we've got to give. So he came to John Laws and he said, well, can you tell me anything about organic matter? And he said, yes, of course, which flabbergasted the farmer, stunned him. But Laws said, just come back in 100 years and I'll give you the answer. So what the social scientists do is they usually embark on participatory research so that the people who are going to use the information, use the data, are a part and an ongoing part of that experimentation. And I think this may be something that we can learn from, particularly if we want to try and build that trust in order to develop in order to be able to make our work relevant to all of society. So let me return to this slide I had at the beginning and say that what I think we've got, besides a social or societal value, we have a role in building trust. Our hypothesis testing provides evidence. It proves things to people. We develop a strategy. We get them to agree that it's working in practice. But of course, there are trade-offs, and there's an acceptability issue. So we need to persuade people. There may be an adaptation loop that's needed so that we go around testing things with people's agreement, with an idea of what is relevant, before we can get round to demonstrating what really works, network people together, and build trust and provide leadership. And there is one of these concepts, again, just before I finish, which is coming into vogue at the moment, and what people talk of as an intersubjective reality, which is something which doesn't exist in objective fact, but exists because we cooperate to make it exist. And money is one such example. If you think about it, you know, it's useful because we trust that it's useful. And there are many institutions that could say much about the same thing about themselves too. Now, I think we need to provide some kind of institution by means of the long-term networks that show that we can be trusted to deliver advice honestly and helpfully and work with people in order to show how they can deliver to more than one goal at the same time, even though one person who's delivering that may lose compared with another one. And if we can do that, we're all going to be somewhat wealthier. So just to conclude, I think that we need to retain options by analysing how we manage the landscape together. But it's not always going to be easy or comfortable doing that, and we have to work as a network or as a leader, provide leadership within the network in order to try and make that happen. And of course, I haven't done all this on my own, so I would like to acknowledge, of course, some of my co-workers. Thank you very much.
Thanks, Andy. Thanks for keeping to time too. So any immediate questions on clarification? One up at the back. I think we're going to have a roving mic, are we? It's on its way. Or a trendy green ball that we can throw around, but for now, here it comes. Oh. Yeah. So you've got to catch this. Well done.
Shall I press it? Or
yes, and have we got some advice on how it works? Otherwise, you can just shout.
Some cooperation.
Okay.
Yeah, okay.
Thank you very much for that presentation. I like your idea of networking farms or farmers, but I was a little bit suspicious. Wasn't it something similar to Soviet Russia?
Yes, it would be great if we could command and control everything. Of course we can't, and that is the whole point about the leadership, about a network, about our being responsible, and about our showing how things can be done, and leading people there gradually. But no, you can't force everybody to do these things. I absolutely agree.
Okay, so we'll have an opportunity to come back to some of these things later, but just for now, if there's any questions, you didn't understand something or want clarification on what Andy said. Otherwise, we'll move on to Bernard. Yep, thanks. Thanks, Andy.
Yeah, thanks, John. Well, congratulations to Rothamsted. Of course, I'm the first speaker who's not from the house. I visited the first time in 1988, when the trials were only 145 years old, so you see how time flies. This is not my presentation yet. Oh. Okay, very good. So I made this presentation with Christian Tierfelder, who's in the room somewhere. He's a colleague from Summit. We've both been working for many years on sustainable intensification. I'm going to talk about Africa and smallholder farmers. And on my note from 200 shilling from Kenya, the backside is actually a farmer harvesting maize, just to show how important agriculture is on our continent. So, Sustainable Development Goals, there are 17, I think they were shown already. They have to be delivered by 2030, which is 12 years from now. But what was not said is there's also 169 targets. And 2 of those targets, especially related to the No Hunger SDG, are very much aligned to what we are talking about today. There is one on doubling agricultural productivity and income by making resources available and including actually non-farm employment, so the vision that it's not agriculture alone that will create development. And the second one, which is really relevant to us, ensure sustainable food production, resilient agricultural practices, productivity increases, adaptation, ecosystem service, and land and soil quality. That's what we are talking about today, right? This is probably the best definition of sustainable intensification so far. So there are persistent problems, and I will not be negative today. There's enough negativity about the continent we are working on, but there's also change. I looked at the FAO stats, very simple statistics. This is showing fertilizer consumption over time between 1995 and 2015 for Mozambique, Malawi, and Zambia, 3 southern African countries. You see Mozambique is basically stable, and the other 2 countries have really gone up. This is the associated maize yields and the correlation between both. Now, you can absolutely not guarantee that all the fertilizer was applied to maize, but in the southern African region, certainly a lot of it was. And you can really see that Mozambique is struggling to remain here, while the other countries are really moving out of that 1 ton per hectare yield. It's simple. What made that happen? There's probably three dimensions that made that happen in those 2 countries where it happened. One is national investments. There were subsidy programs, self-sponsored sometimes supported by the donor community. There was investor and donor priorities who supported those national investment plans. And there's a private sector engaging and emerging on the continent, which was virtually absent 10, 20 years ago. So these 3 things have been really, really critical. I put etc. because there's still probably some other things. There's also some drivers that may counteract this change. It all looks very good, but it's probably not going to be as linear as we all would love it to be. We know about population growth, land fragmentation, climate change. We know there's fall armyworm appearing everywhere on the continent in less than 1 year time. And there's, of course, continued soil degradation, nutrient mining, and everything related to it. Now, the policy context of countries in sub-Saharan Africa. I'm not an expert, I'm a soil scientist, as was introduced. So, which is why I asked Christian to help make this presentation. Now, if you look at the continent, most countries have all sorts of investment plans. National agricultural investment plans, poverty reduction strategies, nationally accommodated mitigation action, and so on and so on and so on. And all those plans have something related to sustainability, to intensification. But usually, short-term solutions are absolutely prioritized, which is probably normal because high levels of poverty do not really give people the luxury to think very long-term. When you go into a little bit of more detail, you see that there's lack of clarity on what that really means, intensification and sustainability. And in some of those strategies, people really talk about it has to be agroforestry, for instance. This is also, of course, complicated by different worldviews of people writing those documents. If I believe that the world has to look like agroforestry, why should I write anything else in a document like that as a consultant to a government? So the result is that there's very little, limited or no learning from long-term trials and anything to do with the work we are doing into policy formulation. They're basically of academic importance. That's what's happening today. There's not only national policy, there's a lot of other organizations. We don't lack organizations on the continent. This is the African Union and all its subcommittees. A country like Burundi is part of COMESA, EAC, the East African Community, and SADC, all those others. So there's enough organizations dealing with policy at the regional level. So imagine you're a politician and you're part of all those communities. So I'm going to divert a little bit now and talk a little bit about sustainable intensification of agriculture. This is in Kenya. You see a lot of small farms. These are farmhouses, the land around it, and no fallow land. So honestly, and we saw the figures of population growth, we know that most people will stay in agriculture for the next foreseeable future. So if we don't intensify production here, where will these people go? Probably not to the UK. But this is also still this photo was not taken 100 years ago, it was taken 2 years ago in the Congo forest. There are still slash and burn systems where people cut down part of the forest, grow a crop for a number of years, and then let it go back into fallow land. So even here, I think we would like to intensify this plot so this forest can be conserved, right? Now, these days we talk a lot about sustainable intensification, and if you look at the literature, you can probably read for the next 3 days about what it means and so on. There's not always nice definitions, but it's usually about 3 dimensions. We need to produce more, making sure that this production does not happen at the decay of ecosystem services, and embed some resilience to shock and stresses, of which climate change is an obvious one. And more recently, there's been other dimensions added in terms of economic, social, and human, and I think Andy referred to that too. So I'm not going to define this, but these are like important dimensions of sustainably intensified systems. I will show 2 dimensions here. There's 5 in my previous slide, but I will forward my talk on 2, because it's not easy to draw 5-dimensional areas. Here I'm putting productivity, and here I've put soil fertility status. I could have put natural resource integrity, I could have put provision of other ecosystem services. And if you think 2-dimensionally, probably this is a sustainably intensified system, where we have high yields, and where all the other services are also maintained. What's happening in this situation, this is again the Congo forest. People cut down a piece of forest, so there's a lot of biomass, a lot of good soil. You start cropping, and you get good yields in the beginning. But over time, of course, both go down, yields go down, your natural resource base goes down. And at one time, what people do is they stop farming, so yield goes back to 0, and they leave enough time for the soil fertility to regenerate, and this cycle continues and continues. It's sustainable, but it's not intensive. The moment you have more than 30 people per kilometer, this breaks down. What happens in this situation in Kenya, people don't have the time to let land go for nothing. So they keep on cropping and cropping until you end up here. And this time to get back to the original situation is not there. These red situations, which are really worst, it's not every single plot that's in this situation. But these situations do exist. This is in Zimbabwe. This plot, this is maize. This is not wheat or onions, it's maize. It had nitrogen and phosphor fertilizer, and there's absolutely no response to it. While if you then apply a bit of manure, you see a very nice, response. This is in East Congo, in the Sud Kivu area. These hillsides here, the soil is gone basically. There's nothing you can do there anymore. So these are these extreme red situations, which do happen, but they are not everywhere all the time, of course. So now, this is our goal. This is where we are, or somewhere on that path down. So how do we move back? How do the pathways that Akim referred to, how do we move back? There's 2 ways. One way is this way, where you start first investing in soil fertility and natural resources, and where your productivity will follow. There's also this way, where you really focus on productivity, increasing yields, and you use the extra biomass to convert to manure or recycle, so you also start building your natural resource base. From experience, we know that this route is not viable unless there are incentive schemes, unless you have payment for environmental services, unless people pay you to do this. Because this takes time, and people don't have time. You have to eat tomorrow, not next year. So this is probably without those incentive schemes, which are on the continent basically absent. This is the sort of operational area where we can work in trying to reverse from where we are today somewhere to the better world. Now, there's a number of approaches that we can follow to that. In our work, we talk about integrated soil fertility management, which is basically aiming at maximizing agronomic efficiency of applied inputs, the environmental question. It comprises fertilizer, organic resources, and germplasm together with sound agronomic principles, and it allows for adaptation to local conditions. This is a trial that we established, one of the long-term trials from 86. We call it an integrated soil fertility management trial, but you could also have called it a conservation agriculture trial. I really don't care so much. So it has the 4 typical treatments, as always. You have a control, you have a fertilizer alone, you have a combination of fertilizer and organics, and you have an organic alone. What do you see is over the years, this is maize grain yield. Your control is about the traditional less than 1 ton per hectare. Fertilizer alone doubles. Organic resources alone is a bit less, but then the combination gives you consistently the highest yields. Yeah. If you then look at variation over time, this is a 20-year period. Again, the average, this is a coefficient of variation. You see that the variability in yields is really quite low in this mix compared to, for instance, the control where you have a CV of 70% over the years. So these are 2 graphs that really show that this sort of sustainable intensification dimension of ISFM is there, proven. What we've also done in that same long-term trial is we've looked at yield and carbon, because the 3rd dimension, the ecosystem service, needs to be taken into account. So these are the data showing, as I said, yield against relative soil carbon, relative versus the initiation, which is 100% at day 0. So this is where in 1986 the trials were. Now if you look at the control trial from 1986 to 91, to 96 to 2001 to 2005. So the control trials without inputs went down from a reasonable yield to basically 0, and the carbon at 50% of its initial content over a period of 20 years. So this is like a new equilibrium, because it's very difficult to go even lower than this. This is the treatment with fertilizer alone, and again you see a downward trend, probably ending up in the same spot. It takes a bit more time. This is mainly driven by soil acidification processes. If you look at the organic matter alone treatment, this is the trends you see. So you end up in an equilibrium, half of the yield, and still carbon much higher than what you have without, but less than the original. And this is where you end up with where you combine both. So in 86, 91, 96, 2001, 2005. So you really end up in that equilibrium stage. So again, this long-term trial shows that based on initial soil condition, which was quite good because it came from a fallow, what are the sort of options? You have to stay in that green-green area, which we could equate to sustainable intensification. Again, this is only 2 dimensions. The other 3 dimensions are as important as these 2. Conservation agriculture is another sort of paradigm that has been advancing quite a bit, which is based on 3 principles: soil manage, minimum soil movement, keep your residues on the soil, and diversify. With the permission of Christian, I've added a 4th one, application of fertilizer to ensure you have enough biomass to cover your soil and make sure you have mulch to keep your soil covered. Again, if you look at this same sketch, probably the integrated soil fertility management sort of interventions, you could place them here. It's really about increasing yield and then better using the crop residues and the other products you have. And probably conservation agriculture operates here a little bit higher, because you need a certain soil fertility and a certain yield before you can have the mulch produced in situ to keep your soil covered. Again, and these are data all from Christian, you see that on average, 77% of the yield result, this is the 1-1 line, this is the extra yield due to conservation agriculture. So you see 70% of the yields are better in the Southern Africa region. Again, another example where a long-term trial was quite critical. This is again yields, and the red line here is the control, the conventional. The blue line is where you have direct seeding and maize cowpea rotation. So the 3 principles. And again, you see over time that this is really the treatment that keeps things moving. But it's probably related to a number of issues dealing with soil moisture. There's better infiltration, reduced erosion, here in these treatments. There is enhanced soil moisture, again in the colored versus the red, and in all climate resilience. So these are two examples that show that long-term trials were actually quite important to derive some of the main lessons in relation to sustainable intensification of technologies. And of course, this other dimensions, as I said a few times, this is work from 6NAP. I think we'll talk about it more today. I've talked a lot about productivity and probably soil quality, the environmental, but the economic, social, and human dimensions will make this whole logic go or fail, basically. So now, getting the message across, I think that was the topic of my talk, right? So we have long-term trials and we have sustainable intensification. I think we start to understand what it is all about. We start to understand how long-term trials help us draw conclusions. As I said, we had the Sustainable Development Goals. We have agricultural policy. Yeah. So this is all we have. Although we observe there is that disconnect between policy and science and application of sustainable intensification. So what's wrong? What's next? How do we link the dots? We're late for new trials, right? As I said, the Sustainable Development Goals need to be delivered by 2030. So if we say, let's plan the next generation of long-term trials, we'll probably be a little bit beyond the Sustainable Development Goals. So the first question, I think, and I think it's also going to be discussed in this meeting, what lessons can we draw from existing long-term trials? Yeah? What is it? I know there was the sort of analysis of secondary information that was initiated after the last meeting. What do we see from it? I've given a few examples, so there's probably a lot more examples to be learned. So what is there? What is there currently? And once we have distilled those lessons, and now I'm probably talking from my very, very limited experiences in the sort of policy debates on the continent. If we have messages, there's a number of dimensions to those messages before people will listen to them. They have to have short-term goals. If you say, well, we'll take like 10 years to get that carbon up, nobody will listen to you. I think Akim made that point also. If you talk about long-term trials, let's think about the 2, 3, 5-year goals and outputs, while of course knowing that there's going to be more later on. We need to include economic information. Politicians don't listen to soil carbon. They listen to US dollars. And billions is better than millions, because their budgets are, in that same. The cost of not acting, of not doing anything, is as important as the cost of, or the revenue gained by doing something. Linked to ongoing debates. Yeah, there's a lot of talk about 4 promille, and I saw there's a session on that. These are the hot topics. So if we can link our strategy and what we do to some of those other debates, I think we could be in business. And absolutely linked to those strategic investment plans. They are often broad and encompassing everything, but donors will only help if you relate to them somehow. So just an example on what I mean with short-term goals. This was a study done by ICRAF in 2009, based on interventions, sustainable land management practices that had been implemented and disseminated earlier on. So there's mulching, improved fallow crop rotation, composting, animal manure, all sorts of interventions that were started. For instance, mulching, there was a promotion campaign in 2001. The survey was done in 2009, which is 8 years later. And at that time, we had 37% uptake of that technology. So that's the table. Now, I've redrawn this table in a graph. So this is, again, percent uptake versus years since introduction. So what you see immediately is that really to have some sort of a uptake of some of those technologies, you need 10 years. Yeah, maybe 5, at least 10, let's say, 10 to 15 years, which is again beyond the 5-year time frame of a political mandate. And what you also see is that some of the dots on the lower side here, even after 20 years, their uptake is quite low. vegetative strips, Vanlauwe are systems where you dig trenches to stabilize hillsides against erosion. And another one, green manure. So some of those are low and remain low because they don't have those short-term benefits. Some of the ones that do quite well, animal manure, crop rotation, which are things that people can adapt immediately and with immediate benefits. So those are the things that really fly. So this is just an example where demonstrating that the short-term benefits are really as important as the longer-term effects. And secondly, the ongoing debates. This is a paper from a few weeks ago, I think. The 4 Promille Initiative. It's a good paper, you should probably read it. But they argue for the need for long-term experiments under carefully controlled conditions, focusing on main elementary processes. What do we don't understand about slow variables and stabilization and sequestration and so. And also look at feedback effects, because climate change provides feedback on decomposition and carbon sequestration and so on. So we need to have the right message, and I talked about, keeping it simple, economics, short-term, and so on. We also need to talk to the right constituencies. I've shown those graphs of all those policy organizations that exist. So donor platforms, a lot of countries have donor platforms. Development banks are investing in agriculture quite more than they used to do. Ministry of Agriculture, Ministry of the Environment. If you go to DR Congo, they are 2 different ministries. So who do you talk to? And they usually don't agree with each other because they want, the overall pocket of money is constant. So who do you talk to? Both. We always say, policy briefs need to be simple and straight because people don't have time to read and so on. That's true for decision makers, but not for decision shapers. That's a term I heard Margaret Quinn use 20 years ago in a different meeting. Decision shapers are those people that advise decision makers and that usually, stay a bit long term. They are usually having the technical baggage to understand what we are doing. So these are probably the people to work with more than these people here. And lastly, using the right enablers. A continuous dialogue is essential. If you go once to see one person for coffee or whatever, and then you think things will change, you're wrong. And evidence and reputation. Why would people listen to you? Who are you? Because tomorrow they will meet 10 other people who will say other things. So just to give an example on the timing, in Uganda we've been helping with the National Agriculture Extension Policy and National Seed Policy. This process took from April 2016 till July 2014 till July 2016, with very many interactions with different people, with different evidence parts entered into the process, and so on and so on. So this was a 2-3 year intensive interaction with policy before things start changing. So engagement is as important as having a good set of lessons learned. Beyond the SDGs, it's very likely that not all our sustainable development goals will have been achieved by 2030, right? So there is going to probably be something else following, yeah? And that future set of goals is very likely going to have an agricultural sustainability dimension. Why not? So then the second question is, I think really important to this meeting, do we need new long-term trials to determine and enrich the evidence base for the SI nature of specific interventions? This is the second, to me, really critical question of this meeting, taking into account all the other points I already raised. Now, if we go into new trials, I think a number of thoughts on what should be taken into account when we plan those. One, let's base them on evaluating principles of soil management rather than specific, I call it paradigms for want of a better word, specific worldviews that you want to impose on the whole world. Consider upcoming issues. There's climate change, there's a big discussion on the role of crop diversity and sustaining agriculture, and so on. And then focus on mechanisms that are less well understood, the slow variables and how they interact with management and all the other drivers. Secondly, and I think that was mentioned already by Andy, let's really embed current soil fertility and socioeconomic conditions in the design. Pathways to intensification, those green, red pathways I've shown, they depend on the initial conditions. If you start somewhere a trial on a very fertile soil and you conclude something and you apply those principles on a degraded soil, it's not going to work very likely. Evaluate, as I said already a few times, short to medium term results, that the trials do generate outputs in the first 3 to 5 years, and really embed those trials in delivering other short-term outputs and outcomes. Let's not isolate them from what's happening otherwise with farmers. And I think Andy also talked about the social pillar of all that work. That's exactly what I meant, but Andy said it better. So in conclusion, some messages, I believe. We have progress made against the SDGs, including SDG 2 and its specific targets, but mostly related to increasing productivity. I can't say the progress against the second target is as much. Sustainable intensification is getting pretty much accepted, although there are conflicting interpretations on how to achieve this. Thirdly, former long-term experiments, they have provided evidence in relation to the SI nature of intervention. I've given some examples of that, and I hope to hear much more of this in the next 2 days. Although there is policy frameworks in Africa, and they get more and more implemented, progress is really, so far, really related to simple solutions with immediate benefits. And I've put between brackets, rightfully so, probably. Engagement with policy requires adapted messages, integrating short-term results, continuous engagement, and reputation. And then if we are really talking about new LTEs, they should address important knowledge gaps, focus on principles, consider initial conditions, and link to accompanying initiatives putting those principles in practice. And that was my last slide. Thank you very much, John.
Okay, thank you, Bernard. Before we move on to the general discussion, are there any questions to do with some of the specifics of what Bernard has covered? If not, we'll move into the next part of the session, which is going to be a panel discussion. So Andy and Bernard are here. I don't know whether we're going to move over to the comfy chairs. I suspect we'll just loiter around here. So it was very nice that we had some emerging themes coming out of what we've heard this morning, not just from Bernard and Andy, but more widely as well. I certainly made a note that the LTEs are important for providing that evidence for building systems, but there's a real question of the relevant scale that we apply that at and how we communicate that and how we make that known. So in terms of thinking about the impact of our experiments, the 2 key words I've noted down are relevance and exposure, how we make them relevant and how we make sure that the right people get to know about them. The fact that we're all here indicates that we get it. We understand the importance of long-term agricultural experimentation. However, our challenge is to communicate that in concrete ways to the rest of society, to demonstrate why they're important. Because the danger, and it's been alluded to a number of times, is they just become scientific curiosities, or they become self-serving for us. And we're very good at talking to each other about them, but people outside of our community don't really get it and understand the importance of them. So I'd prepared just 3 slides, which are now, I think, largely redundant because they've been covered by other people. Some pictures have disappeared from there. This was some of the material I can touch on this. What I've done is I've just compared the world when John Laws was around, and John Laws was setting up Broadbalk, and the world we're in now, just to demonstrate that actually the context has changed dramatically and radically. So the first line there is the world population, and you can see how that's increased. Issues of climate change would have been completely foreign to John Laws and Joseph Gilbert 175 years ago, but obviously a huge policy driver for us now. That illustrates what we were looking at, the good news of yields increasing, and actually because of that we're able to reduce the amount of land we farm in proportion to the number of people that we've got. So it illustrates that the context that we're in now is completely different, and so we need to think very carefully about how we use experiments that were set up for one purpose to address different questions now. And the three pictures I had down there were three species that have gone extinct since John Laws was around there. I had the passenger pigeon and the Tasmanian tiger and the great auk. So biodiversity and loss of species has also been a big driver. We've touched on this. All my slides have gone to pot, so maybe I'll just getting all my pictures have disappeared. We touched on this. What do we mean by sustainable intensification? I don't intend that we spend the next 40 minutes trying to define sustainable intensification. We all kind of understand what it means, and I think Bernard very helpfully touched on the three components of that: resilience, ecosystem services, and productivity. That's just a definition from Jules Pretty, and I had a screenshot of his paper there, but don't worry about that, and let's see what comes up on here. Nothing. Good. But you've seen those already, and that was just going to be the 17 sustainability goals. Was that in your presentation, Bernard? Yes. I wonder if I might try and flip back to that if we need it. Okay, so we're at the stage now where we've got half an hour before lunch, so I'm going to open up the floor to any questions or issues that you want to raise, and let's have a useful discussion around some of the things that have been started by Bernard and Andy. Who's going to start? Okay, Keith. Can you just give a quick tutorial on how that green ball works? Do we have to press it?
If you just talk into the black spot, then you'll get her.
Okay.
It's a microphone. Novel technology. Bernard, you talked a lot about the time needed to take information from long-term experiments to policymakers. What about the language? Because we're used to talking to scientists and we use scientific language. Is there a better language, a better way of talking to people who would take action based on what we know?
Do I reply?
Yep.
Yeah. I don't know if, is this still...
Yeah, you're still on.
Yeah, okay, yeah, thanks. I mean, I think I've already talked about one type of language, the language of dollars. Yeah? Dollars, and you know, donors and policymakers both know that language really, really well. Yeah? So that's one thing that really talks. The other language that talks very well is anything related to those national investment plans. If you want to get support from some of the investors in our world, they need to talk the language of those investment plans. Yeah? I think in science, we are often too, if you see on what basis politicians often make decisions, or on what basis that does not exist, they make decisions. I think one mistake we are always making is to try to be too confident and too, you know, we need to be sure 99%, but really if it's 50% sure, it's where to start the dialogue. And that's where we as scientists are really poor. And that's probably why not a lot of scientists become good politicians. Because policy is about weighing things and moving forward, and you will never have all the evidence base you need. Yeah.
Yeah, well, Akim had a slide up, didn't he, about the things that motivate people. And one of them was urgency, I think, if I remember the slide rightly. And I think sometimes a lot of the things that we want to do, you can't attach dollar signs to, and they don't seem very urgent, but they become overwhelmingly important. And if you remember Bernard's slide, it went down towards zero. Before you get there, there's a point where it becomes urgent to take action. Yep. And I think it's pointing out the trend, but having the evidence from experimentation to show that you're heading in the wrong direction and that you need to take action before it becomes so serious. So it's kind of using those things that worry people, but using them in a productive, constructive way, I would suggest.
But it's a question for both, especially for Bernard. If we're talking dollars, I fully agree. But then probably, if you look relatively, donor dollars is peanuts. Policy dollars, frankly speaking, are also not the biggest dollars that move around. then probably we should be talking to the people sitting a couple of kilometers from here in the city. There's this group of people working with insurance companies related to business continuity of food companies, and there's this group of nice people that are called actuaries who develop models related to risks, scenarios, indicators, and investments are targeted to playing probabilities of system risks, because there's the big dollar sitting to that. So how do we open, and they really need hard data combined with probability. Yeah. So maybe we should be more talking to them, than, which I think is a big policy shaper, because policies listen to, and policymakers listen to investment companies, listen to dollar streams.
Yeah, no, I agree, and maybe you need to help me because I'm not so familiar with that well. A lot of the private sector investments currently, it's called corporate social responsibility. So it's like 1% of the total net income, isn't it? Those figures could look often quite large, but it's because the total money made is super large that those investments are. I agree with you. I was talking to one of my colleagues yesterday that the European Union had invested too much money in Africa and they don't see results coming up. But if you look at the figures they've invested, and if you look at the same time how much money is spent on European agriculture, it's peanuts, really peanuts. We always think in Africa we'll change the world with $2 million. It's not going to happen, so let's talk more. I agree with you.
Follow up, I actually think it would be a mistake if we position our work in CRS, in corporate social responsibility. I think we need to position it in business continuity.
You need to, in business, in making money, in investing. Yes, I know, but what I'm saying very often, that's where it ends up today. Yeah, I agree with you.
Can you just pass it back to the gentleman at the back, because his hand up was up first. I don't know if you can. Thank you. I think that's a really important point as the ball is going back there in terms of farmer practice and influencing farmer decision making. Yes, the agronomists, the policy makers have an impact, but the markets have a huge impact on farmer practice and cropping. Yeah, thanks.
Thank you. Well, on the one hand, I agree with Vanlauwe that policy is primarily linked to dollars and short-term goals. On the other hand, when we try to holistically evaluate the sustainability of a particular farming system or compare different farming systems, considering economic sustainability in there as well, I think it can become misleading. For example, sustainably produced goods could be made economically sustainable with appropriate economic tools, for example, true cost accounting. So on the one hand, with the generic calculation, it might sound that the industrially, so with the goods produced with conventional industrial agriculture are cheaper, economically better, but when you take appropriate measures, they might sound different. So, I mean, there is a little bit more complexity than simply linking things to the dollars.
No, I agree with it. I mean, there's no, I can't disagree with you. Yeah. The only thing is, if you go into those environments that I've talked about, yeah, if you really visit some of those places, those people need solutions tomorrow, today actually, not in 5 years' time. I'm not contradicting your vision. It's the same vision as I have, but the difference between where we are today and that vision is long for a lot of places. So what do we do in the next 2 to 3 years, the short term? Pedro Sanchez in his Nature article talks, let's first move the yields from 1 to 3 tons of maize, which is possible without too much innovation. It's basically a logistical problem, it's not a technical problem. Let's do that. Once you get to the 3 tons on average, people will start competing with the external markets, they will start getting a little bit of income to pay school fees. And then we can talk about the sort of things you've raised, from your 3 to 5 to 7 tons. Then we can talk about all those other things, but that first step needs to happen first. Otherwise, we are not going to reach that second step. Yeah.
And I think I would argue strongly too that it's much more than just dollars. But as the previous questioner pointed out, there's value to be obtained from reducing risk. And if we can make that clear sometimes, it can be a strong argument in favour of sustainable practices.
Okay, so the gentleman down the front here, next.
Go on, chuck it.
Go on, I think the idea is just watch your heads. Whoa, great, very good.
That's fun.
Thank you. Well, Paul Maeder from FIBL, Switzerland. Well, I liked very much the concept of conservation agriculture, which is broadly accepted with minimum soil tillage, diverse rotation, including legumes and residue management. And you added also then balanced nutrient addition, not to deplete soils. My question is, do we not, again, simplify a complex system? In India, to my knowledge, in large areas, huge amounts of nitrogen is applied. We have a surplus, we have water contamination. Do we not repeat now, or if there is a certain risk in Africa, we just say we have to apply fertilizers and all problems are solved? To my knowledge, only 20% of nitrogen which is applied to wheat is then taken up by the crop, and still there's a huge problem of optimization of, we may also address recycled fertilizers, compost from municipal waste, also digestates, sewage sludge, and so on. I think we are, in my opinion, too much concentrating on chemical fertilizers and are not enough considering the whole cycle from urban to rural areas and back.
So I think Andy MacDonald showed some results from experiments here where adding organic matter seemed to improve the rooting ability for crops, and that they were able, therefore, to recover more water and more nutrients than they otherwise would have done. So that's certainly a value of the long-term experiments in that regard.
I'm going to very much disagree with you, as you know. And I'm a good friend of Paul because we do have our trials together in Kenya, where we look at organic systems versus conventional systems under high and low input. So we are colleagues and friends. But you're comparing a situation in India. In fact, once I was in a meeting, and there was somebody from India saying this green revolution was so bad for us. It killed the environment and whatever. But he didn't talk about the millions of people's lives it saved. It was like secondary. Yeah? So I think there is really a big difference between where we are today in Africa and where India is today. And I think in India they're also doing a lot of efforts to reduce those input rates and work on efficiency. At least I know of some of projects that try to do that. But they've taken that step from 1 to 3 tons. Maybe not in the smartest way, but they've taken it. Now they can work on the other things. In Africa, we are still down there. Yeah? In Africa, we are still at very low rates of nutrients. Without, Paul, I've done all that work on organic matter. I've done it really for 15 years. The municipal waste is very good if you can valorize it. Absolutely, let's do it. Why not? The legumes, very beautiful, all those very nice things, but you will never get enough to take that step from 1 to 3 tons, only using those organic resources in those systems in Kenya that I've shown. In the Congo forest, it's possible, but you have to kill some of the forest. So I think the middle of the road is the best way for most of us. And my last point, and really, I'm not the one to take that decision. If I go to smallholder farming, that person is sending his children to school, making some money, eating less than $2 a day, managing all those different systems, surviving. If you would put me there, in 1 week time, I will go to town and start begging, because I can't keep that system running, but these people do. So I'm not the person to say, you have to do this, you have to do this. My job is to expose to people what's possible, what you can do, what are the pros and cons, and move that way. Yeah. So yeah.
Can we just Christian and then David.
Edward has been having his
hands. Yeah,
I just want to add to what you just said. I think your data clearly shows that combinations of different technologies thoroughly put together will probably give the best return. Yeah. And that applies also to the organic resources, the green manures, the legumes, the fertilizers. They all are part of the solution. Yep. I don't think that one can do it, as you have also showed in your slide on Zimbabwe soils. Yep. If you just apply enormous amounts of fertilizer, you won't go anywhere because the organic carbon is too low. So the combinations, I think this is what we have to prove. And also the long-term trial in Rothamsted shows that. Combinations are the most successful ones, I think.
Yeah, exactly.
And David, and then back down to the front. I think somebody's been waiting
to give the hand
for a while.
to
over there, yep. Yeah. Okay, over there next. Yeah. Sorry, out of my field of view.
Yeah,
Thanks,
thank
David.
you. David Paulson at Rothamsted. Yeah, I would agree with the points that Bernard just made, that, of course, fertiliser is not the only thing we do. All the organic matter, all these things are important. But I'll give you a quote, actually, about fertiliser from Christian Pieri, who is a very well-known French agronomist, perhaps from an earlier generation. It probably means the same as my generation. But he once commented something along the lines that, okay, in some parts of the world, and parts of India and China will be like that, fertiliser use is way up here, and of course it should come down. But that does not mean that in other places, like in Africa, where it's way down here, we should not bring it up to something sensible. So the two, you've got both situations in different parts of the world.
Exactly.
Saying we should use less fertiliser in one place does not mean you should use less somewhere else.
Can I make one comment, David? Please, let's stop saying that in Africa it's very low and down there. It's changing. And if you look at some countries, it's actually changing quite, there's a bit of optimism. It's not, if you look at the aggregated data for the whole continent, it remains quite low. But if you look at some countries, Ethiopia, Malawi, Tanzania, Nigeria, it's really increasing. Not to the levels that we'll have in China. We'll never get there because it's economically even not wise to go there. But there is that drive, and you see that 3 tons becomes really in reach. So that's the message you need to start giving. If you keep on saying everywhere it's so low and it stays low, people say, what do we do then? Yeah, just the point I wanted to add.
Okay, yeah. Can we get it over to the left? There we go. Good shot.
Oh.
All right. I am Edward Debois from CSIR Soil Research Institute, Ghana. But we have seen from the UK situation how wheat yield increased from the 1843 from 1 ton to about 8 tons currently, and probably more. If we go back to the Africa situation, where we have maize also being highlighted, do we foresee a situation where if we go by the productivity pathway, we could move from where we are, 1 ton per hectare, to a situation where it could be comparable to what we find in the UK situation? That's the first point. And then the second one is, if we really want to concentrate on the productivity pathway to really increase yield, what options are there for us to look at without considering the soil fertility option, which you indicated that might not be the way forward for Africa? So if you can highlight on the productivity pathway, what options are there for us as Africans to really increase the yield?
Perhaps I should just point one thing out, is that the conditions in the UK are relatively benign for growing crops and certain crops. The soils are really quite fertile as a result of relatively recent glaciation, and that the climate is a combination of not too wet, not too dry, not too cold, not too hot. So some of those quite remarkable increases that you can see on the long-term experiment graph are partly our managing to the best possible extent the benign climatological and meteorological environmental conditions we've got. However, that's not to say there aren't great things that you can do in Africa, and I'll let the expert take over.
Yeah, Edward, you know the answer to your question, isn't it? Yes, you know. And the reason is, it is possible because it is happening today. But it's happening very easily under large-scale commercial agriculture. People in Zambia get 8 tons, 10 tons per hectare like they do in England. It's possible. Even in Nigeria, if you have 40 ton per hectare, 60 ton per hectare cassava, it's possible. So what I said is a logistical problem, it's not a technical problem. And logistics means, you know, the markets, you need to get the right inputs, the economics need to fit, economies of scale, all the other logistics. There are technical issues, of course, and we do have specific constraints that will stop that process moving as fast as we want it to go. There's new pests and diseases that are coming up, all sorts of other things. For your second question, please don't misinterpret that graph I made. The axis soil fertility, I should have probably put other ecosystem services beyond productivity, which was on the y-axis. Of course, you will not increase your productivity if you don't do anything on your soil fertility conditions. So, you know, all the things I mentioned about the things we've been talking, a bit of nutrients, a bit of organic matter, a bit of good agronomic practices, the weather, everything. I will make one more statement, and you know, David used the statement. There's somebody else who once said that scientists in Africa think they are so smart, they will find other ways to increase productivity than what has been done anywhere else in the world. Yeah, anyway.
As it's going back to Sieg there, if I can just add a comment. It's important to remember that those increases in yield have come with some unintended consequences that we're dealing with now. So I put it that there are some fault lines in the green revolution that are starting to open up. And there are some farmers in the UK who are now struggling to keep 8-10 tonnes per hectare because of resistance to pesticides and herbicides. So there are some fields now where we cannot crop winter wheat because we can't control the weeds. So our advances in crop breeding with our modern cultivars, we only achieve those potential yield gains when our crop protection products are working and when we put lots of fertilizers on. So the two fault lines in my mind are resistance to pesticides and soil health and soil function, because we've driven down our soil carbon and organic matter. Yep. So we can't just think we've got all the solutions, and if we get to the top of that broad graph we've arrived. I would argue that we need a slightly different trajectory that avoids some of those unintended consequences and avoids those fault lines opening up later on. Sorry, Sieg.
And I would add environmental emissions to that as well. Yeah. We're losing quite a lot of nutrients to the environment.
Yeah, those are really important points. I think we all agree in the room that we need a greener revolution in Africa, right? So that we don't push the planetary boundaries more than we have already with biodiversity losses and nutrient losses. But I would just push also the conversation a little bit. These long-term trials in Ghana and Kenya that we're hearing about are really important. But in addition to that, I would make a case for, when we talk about yield gaps, we all know how to get the 10-ton. The maize 10-ton club, there are farmers in that in Malawi today. But there are also many farmers not achieving. We just published in Nature Plants that actually the NDVI, the remote sensing signal, is not as optimistic as we would hope it would be. In fact, it's going down in Malawi despite the massive amounts of fertilizer. Perhaps it wouldn't have gone even down steeper, I don't know, without the fertilizer inputs. But the point is, some of our recent work on farm surveys that are complementing long-term trials are finding that Striga is really a huge driver of this. So that possibly is related to soil organic matter declines. Probably other weeds are big problems. So we need to do diagnostics of yield gaps. We can't just use long-term trials because we tend to put them in places that have higher fertility, that are flat, that probably don't have the shallow soils that we deal with around the world. So farmers have to deal with topographical variation. They have to deal with parasitic weeds. So we have to challenge ourselves, perhaps, to think about how can we do long-term trials and understanding yield gaps at scale, not just in particular places that are somewhat mesic. Thank you.
No, yeah, sure. I mean, that's one of the last points I made too. You know, let's be very recognizant of what are the issues, what are the initial conditions, and build on that. Striga is a particular issue, of course, and you said soil fertility and whatever. Yeah, there are interactions with soil fertility, but Striga is a management issue. You can manage it away, but then again, it comes, you know, at trade-offs with all these other functions you have to do at the same time. Yeah. Okay, let's see. Is there anybody who's had their hand up for a while? And
Okay, let's down this way first. Down the front first and then at the back. Thanks.
It's a little bit of a gender
Sure.
It's a little bit of gender bias.
Yes.
My name is Benny Bar Yosef from Israel, and I want to raise the question of using models for managing agricultural and environmental systems. My impression is that the current state of knowledge of modeling allows us to replace, I would say, considerable part of the experimental work which is being done. For example, if you want to see now what is the effect of composting on yield in a certain country in Africa, I believe that we could use models to estimate it. It will be cheaper, it will be faster, and sometimes it will give solutions which are, predictions which are as good as experimental work. Now, I wondered what is your opinion about the status of models today and if it can really replace experimental work.
Well, I think I'd always be pleased to talk modelling up for all sorts of reasons. But I would also caution about overusing them. I think they are really good for expressing the content of knowledge that we have, and for, you can think of them as a hypothesis or something that evaluates a trend. I showed those graphs of the various ways in which long-term experiments feed into science business policy. I would be a bit cautious about applying those models in areas where they haven't been tested, validated, or where they're not known to work. What they might well do is outline gaps where more experimentation could be formed. I'm very much a fan of using models in association with data in order to try and improve both. So yes, I'm quite sure that there is models can be used as an aid to developing policy and business because of the knowledge that we already have, and see that used more widely, where it would be expensive and perhaps not of great value to do additional experimentation. But I would be a bit cautious about saying, right, well, we don't need to do any more experiments whatsoever, just use these models. We're always finding out more things. We're always finding out how to model better, and we should always have the modesty, the humility to say, we don't know it all yet.
Excellent. So where were you aiming? Yeah, okay. Okay, well, that gentleman at the back was first, if we can have that first.
Thank you very much. So I think this is very good. I'm Xu Junliu from China Agricultural University, Beijing. First of all, I would like to say that's a very good results from Chinese government. Last year, we found China's chemical fertilizer consumption reduced for the first time in the last 30 or 40 years because of the contribution of long-term experience, not only from China, but also from Rothamsted and other countries. So I think this is a very good signal with the contribution of long-term nutrient management induced achievements for improving nutrient management in cropping systems in China. For the long-term experiment design for future food security and environmental safety, my suggestion is in the future long-term experiment, we may focus on the systematic design for comparison of future sustainable intensification, because only single fact comparison is not enough to do the long-term experience. We have many traditional long-term experience. And we also should think about the multiple monitoring systems and multiple monitoring approaches, including remote sensing, traditional monitoring, and integrated modeling evaluation for this of integrated information for not only food security, soil quality, and environmental safety. Okay.
Yeah, thank you.
Yeah, I think there's a lot of truth in that. I mean, when I was looking for data for environmental problems as well as yield at the same time, I was horrified about how little long-term good experimental data there is. So the more things we measure together, the better, I think.
It's interesting what you just said reflected very much the discussions we've had over the past couple of years about a new experiment. One of the things had to be, it can't be single factor. We had to assess multiple factors. It had to serve models, and we also needed to instrument and measure lots of things. So thank you for those points. Yeah.
Okay, my question is related to the SI, and the SI is really, it is taken as a tool really to see the African green revolution. Though it is, there is a hope to happen the green revolution in Africa. Of course, there is no doubt SI can bring the green revolution in Africa, but really, as you said, there is a logistic problem. And do you think really there is appropriate governmental policy, mainly the agricultural policy, that back this tool really to achieve the African green revolution? Because from my experience, I see there is really no appropriate agricultural policy in Africa still. For example, as you said, over 15 years or over 50 years, the European Union, they give aid to Africa, but still there is no really reduction of poverty. If you take poverty as a tool, still most of the people are poor. The level of income is decreasing. Really, what are really the systematic problems behind all this? Really, do you think without solving all these problems at policy level, can we really attain the African Green Revolution using really this interesting tool, the SI?
You know, if it takes some positive change to continue working in a certain environment, isn't it? I've been 27 years on the continent. If nothing would have changed and all the time you hit the same walls, probably I would have been in Rothamsted instead, or somewhere else, isn't it? So what makes you move is because you see those changes happening. What you're saying is a general statement, and the continent also suffered from generalities. If you really go into some places, Rwanda, Ethiopia, parts of Nigeria, you see these things happening, what you're talking about. And it's very much driven by either government investing via donor funding or their own funding, or via private sector companies starting to get engaged and be there to make money. So these things are happening today. But you need to look at them. And it's a bit, again, a worldview, isn't it? If you want to see the bad picture, you'll see it. I'm looking at the good picture, and that's what I'm trying to work with and advance.
Of course, the big problem is if we come to the specific from general, it is as the long-term trial of 175 shows really integrating, for example, if we take only one dimension, integrating mineral fertilizer with organic substance or with existing knowledge, just sharply increased the yield by integrating the improved variety and also plant protection. Those improved variety in the plant protection needs investment or input. If most of the society are poor, really how can they invest on fertilizer, on improved variety without subsidy?
You should read the DFID strategy from 2015, yeah? Because you're again making a general statement. Everyone is poor. It's not true. Yeah, of course people are poor. They are not like here in Europe or whatever, but there is this 20 to 40% of the population that can invest, that have the land, that have the labor. And the latest DFID, well, it's already 2-3 years old, but the DFID strategy recognizes that there is a big sector of society that will not be moved into sustainable intensification. They will be poor forever. And then in that strategy, which is again very enlightening to see it from a donor, they then say, well, we'll need some safety nets or social support for those people. What happened in Europe is those people left agriculture and go to work in factories. But that's not happening on the continent so far. So there is those people in those environments who actually can invest.
Okay, I'm going
and they invest.
Things to a close. Thanks,
Yeah.
Bernard. We've opened up some really interesting avenues of discussion. We've got a couple more days to explore those in various workshops. But for now, if we can just thank Bernard and Andy for their input this morning. Thank you. Thanks, Andy.
And thank you, John, for chairing that. So it's lunchtime. Please remember to sign up for the tours. If you've booked in for a sample archive tour now, then get ready to meet the people who are taking you over there. There's plenty of time for that tour and lunch as well, so you won't miss your food. Don't worry about that. Also, the tours of the museum are available. What I would say is that this afternoon, we're beginning to move into the more challenging sessions, when some of you have been given just 10-minute talks. What we wanted to do in this conference was not have a traditional conference with talks, lunch, talks, dinner, talks, tea, but we're having focused talks of perhaps just 10 minutes. So this afternoon, those of you who've got 10-minute talks have a real challenge to give your talk within that time and to help the chairs of that session. So get ready for that. Enjoy your lunch, maybe a bit of sunshine, one of the tours perhaps. Sign up if you need to, and we'll see you back here at 2 o'clock. Thank you very much.